Okay, I think we're ready to begin. My name is Dipansh Khurana, and I have with me Pavel Demin, who is my friend and colleague. So today's workshop is called Do It Yourself, Unclog Your Scripts with Plumber API. Again, I'm Dipansh Khurana from Epsilon. This is ShinyConf 2025, and we're going live now. Of course, I have to thank you, Pavel, officially for helping me out and lending a hand. And here it is, you in the big picture.
Thank you, Deepansha, to be here. And I will be around in the chat answering questions most of the time.
And I think we'll bring Pavel on stage later as well for a discussion, but you can count on him for all of your questions and anything that you want to ask about the topic, about most of the things. I think he has a better grasp on things than me. If I want to be that humble, but then I am being honest as well. So he will answer your questions. And on to what we will learn today in this workshop. This will be a short presentation, after which we'll follow on with a coding example. And that example will be shared with you as well. What I'll do is I'll quickly leave a link in the chat for the slides and the GitHub. So I think that should, now that we're done with that, here's what we learned today. We learned REST API 101. That's a very simple class. We learned requests and responses. We learned HTTP status codes and some relevant packages. Then we'll build an API with Plumber. So just to give you more context, last year I gave multiple talks on how to build an API for your life. And I realized that I kind of left out the most important part, which is building the API. So this is more or less the catch up in a way to the other sessions. But let's begin from how knowledge gets siloed in companies and in organizations. Let's say you're a data analyst and you once asked the question, how do I share it with the rest of the team? And of course, you must have thought of making a package. You must have thought of making some sort of shareable script. You must have thought of making a zip file and so on. There are many ways to share code, but that is not that fancy, to be honest. And I think Pavel was the one who said that Plumber is shiny elitism. So probably taking that thought forward, well, make an API, because then you can go from analysis to service, and you can start giving the code that you've built in a black box to people all over your organization to use it. Um, and now I think we can go into the basics of REST API. What is an API? Well, it's an application programming interface. And REST stands for representational state transfer. But that doesn't tell you anything. And neither does that tell you anything actually. So what are APIs? Well, they're taco trucks. Think about the last time you grabbed a quick bite from a taco truck or any food truck, probably because you cannot make tacos like them. And I think that's something that all of us have done before. And that's how APIs work. They are essentially taco trucks where you get what you want from a web server. A request gets a response. And hopefully it's a really good taco. So I hope that puts things in perspective of what APIs are. Of course, we are talking about building them and not consuming them, but then how things are consumed is I think, even more important to know before we start building them. Because if you don't know how something is being used, you will not be able to build it in just the right way that is required. And let's go into a bit of technicalities from that analogy, because this is, after all, a workshop. So there was once a computer or a phone, if that's a phone. I'm not sure if that illustration does a smartphone justice, but let's go. And then there was the internet or server. And the phone said, hey, I need that data. And it did it through the API. And the server said, wait, let me just crunch some data. And the server sent it back with the API. So the API is, in a way, the interface between both of these two sources. And one makes the request, the other makes the response, and this is how the communication follows. Of course, there are multiple ways to do this. We will mostly be covering, because Plumber helps you make REST APIs, we'll be covering REST APIs, which is again a fancier way to say you make a request and you get representation and a response, and the representation is shared between you and the server. So what makes a request? Now that we've said that word multiple times, we should know what it does. A request has a method, and these are verbs. You will, of course, if you've done any sort of programming in web services before, you will probably know some of these, especially get and post. And mostly for our workshop, we'll probably just be diving in Get. And there are, of course, others. These are just for examples. There are also Patch. There's, I think, a few that we can also use, but which are usually frowned upon in modern web development. And then there's URL. This is the address to the server. Of course, it also has some parameters. If you've ever, if you see the link in your address bar, if it will have a parameter in the end, it might be getting something from an API if it's a get. But then that's not as simple as that. Uh, and then we have headers. Headers are metadata, which is information about your request. So information about your request can include authentication. It can also include some additional information that the server might require from you. And then there's the body. The body is the additional content that you need. For example, if you're putting data into a database with the, of course, put method, you would send the data, as well as post. Post is again the most commonly used, I think, method to put something somewhere. And again, that's a bit confusing. But then post is, I think, post and get. If you know two, I think you know all. And what comes back in a response? So what comes back is a status code. Everyone is familiar with the 404 error because we've seen that a million times. But there are others. When you don't see an error, for example, in this page that's working perfectly fine, you probably have a status code of 200 all over. But we don't know that because it's working just fine. And we'll talk about what status codes are. But essentially, you get status code, you get a status message sometimes. We'll see this in action as well. Headers, metadata that was sent, as well as something that the server probably wants to send, and body. This is the most important part. This is the response in JSON. So this is something that you would use. This is essentially the taco that we earlier talked about. It's nicely wrapped in the tortilla of curly braces, and I think that's a pretty good way to think about it. It's packaged with all sorts of toppings in it. And now let's think about HTTP status code categories. A table will pop up in a second. I just want you to know that there are definitions that Wikipedia has, and then there are true meanings. And as a programmer who doesn't really like to be bogged down with the technicalities too much, I think we should always think of things in the easiest way to understand them. And I think the true meaning is really what you really need here instead of the long definitions that are on the web all over. So if you ever see a code that's one something something, it means the request was received and the process is being continued. In practice, you will probably never see this family of codes, but that just means things are going. And if you see anything that's 2xx, or for example 200 that we just talked about, it means the request was successfully received, understood, and accepted. That means everything is okay, things are working fine, and here's your response. The family of 333 is further action needs to be taken in order to complete a request. So a moment. If you've ever seen a 303 redirect, that's pretty much it. You visit a URL and then you go on to another URL. One example of that is the link that I just shared. You see a go.epsilon.com and with some sort of word there, and then you go to the actual links, the slides, and the GitHub. So that's something related to the 300 family. Then there's the 400 family. Again, the notorious 404 comes from this family. There are others, of course. 403 forbidden is something that you will face much too often if you try to access data from someone else's API. Because if you don't have authentication, it will almost always be a 401 or a 403. So this just says can't, sorry. And the 500 family is the server failed to fulfill an apparent request. And that's just an oops. Nothing worked. Something is wrong with the server. Let's go. But you don't need to memorize all of them. These are the codes that you will see most often. 200, again, okay. 201 is created. So if you create a file, if you are writing to a database, I think you'll still get a 201. 400 is a bad request. It's, for example, you sent a parameter wrong. Maybe you spelled it wrong. Maybe it expected another value and you sent it in the wrong way. 401 is unauthorized, as I said. 403 is forbidden. These two are often used probably by people who create APIs more or less interchangeably, but then they have their own specific semantic meanings as well. 404 or 404 is not found, and 500 is internal server error. If you ever create an API, I think 500 is something that you are bound to see most often because then you need to go back into your API and the code and start to debug. So I've in the last few years seen 500 the most often, and I hope you don't have that fate. But then if you start building APIs, you will. So there are some packages to know. There's the HTTR, HTTR2. HTTR is from base, HTTR2 is from the tidyverse. These let you access APIs. We'll see an example of this towards the end of the workshop. Then there's that should be JSON Lite, and that's a typo. So if this was a real life API, this would not go through, and you would probably get a bad request. And then there's Plumber, which lets you make APIs. And then there's curl, a low level usage. If you are familiar with Linux or if you've ever made a curl request yourself, this is just something that lets you do curl inside of R. But then if you are already inside of R or in R Studio, you would probably be using curl from the terminal. But then if not, then there's a package. Of course, for the purpose of this workshop, this presentation, we're focusing only on Plumber, which is make APIs, but we will touch upon the others as well. Okay, so all that is just, I would say, the preamble to a very, hopefully very interesting class. But we will see an API in action just now. So what I want everyone to do is to take out your phones or you create a new tab and you enter this address, catfact.ninja/fact. If you do that, you will, and I'll give a couple of minutes to everyone to kind of just do this, try it out. And if you open, you'll see something like this. You'll see a fact, which will be a sentence about something about cats, and then you will see the length of that string. So if you manage to get that to work, well, you've accessed an API, and that API can be run from your browser because it has no authentication. It's just a placeholder API. Placeholder APIs are spread all over the internet. They help you debug things, they help you check things. It's pretty much the bread and butter of how you make a system. Because if you want your system to interact with an API, instead of just putting placeholder lorem ipsum or something like that, you can actually use an API to test things out, and then you will see that your application is able to make correct requests. And I think this is something that I use. There's also, I think, a quotes API. There's also, I think, one that generates images. So again, the world is your oyster, and the internet has one thing for everything. So if you already tried this out, I would be glad to see some messages or some reactions in the chat. And then we can move on to the next side, which is if you change that T to an E in the same URL, you'll see another API response, which is an error. So you'll see a message and a code. So that will be a 40404. And I see there's already a fact here. Jaguars are the only big cats that don't roar. So thank you, Ulrich, for sharing that nugget with all of us. And I'm glad that it worked. If you all try changing it to an E, you'll changing it to an E from fact to face, you'll see that you'll get an error. So this is a perfect example of how APIs work. If you had a data, you get something, and if you don't get anything, if it's a bad URL or a bad response, you see a not found. And I'm glad that everybody is getting to try it. If anyone wants to look at cat facts, the chat is now available. Thank you so much for every person who posted, and thank you, John, for writing a book about APIs. I think I am your first reader. And if you are not aware with John's community, I think you should join it as soon as possible, because it's, I think, one of the most important resources that you can use as an R developer to kind of get help whenever you need it. I'm also there as a mentor, although I try my best to be as available. I do falter now and then, but again, you should definitely join John's community. And I guess it's everyone's community in a way, as John would put it. And now you know everything, more or less, that you need to build APIs. So let's get to it. And now I'll request everyone to open the GitHub, and I'll go there as well, share my screen. And before we go into our coding section, I placed a poll which asks if you've used GitHub before or not. So you're free to submit your response. Of course, I see that a lot of people have. So most people here have used GitHub to get code before. If you open that Git window, you will probably see something like this. You'll see a repository. Can we bring that? I think I can bring that to the stage. So you'll see the repository like this. If you are familiar with Git, you can pull this because this is a public repository, or you can use RStudio. We'll walk through that as well. If you are not familiar with Git, you can also download a zip. So if you go here and if you see the drop down, there will be zip. And we'll give you enough time to be ready. So what we can probably do is we can get Pavel on stage and we can take a few questions about these theoretical aspects. Meanwhile, everybody tries to get set up. And I think then we can move forward with the workshop. I think a good show of hands would let us know that you are able to access the GitHub. So maybe a thumbs up in the chat, or maybe we could create another poll. Either way, it's fine. I think we can just do reactions in the chat, and I think that's the fastest way. So push a thumbs up if you are able to get the code from GitHub or at least access the repository. If not, we'll go into maybe some questions that you have. And if there are no questions, then I think I can move forward with the workshop. So if you are using RStudio, I hope you are, because what I'll try to do now is just pull in this repository from GitHub. And I see a lot of thumbs up, so I think we are good to go. I think there's a GitHub link quite above in the chat. I'll probably just copy that down again. Yeah, thank you so much, Pavel, for that. Maybe we could pin that as well, if possible. Okay, I see most people are, at least quite a few people are now getting set up, and we'll keep working towards this setup phase. And let me just quickly open up RStudio and share it with you. So now we have this clear RStudio window, and what you can do here is you can do a new project, and instead of just opening it from GitHub or opening it directly, you can actually go here for version control. You can do git, and you can paste that URL. So I'll just do that. I'll change this here because I already have that pulled. And if you do just create project, it should clone into things, and you'll get that project set up. Now, of course, we have 3 different projects here, so this may not be ideal. And what you can then do is, now that you have the repository, you can also go here, open the first one, and open that into RStudio. So it'll just switch that project. And again, this is the most clunky way I could figure out to include 3 different examples. I think I need to be better at this. But again, if you are able to open that first project, you will see Plumber Basics, and you'll see a couple of scripts right there. And then you'll see this renv.log that opens up. So if you see this bootstrapping renv and this installing renv and everything else, you're probably in the right shape right now. And just to check that we have all the packages, we'll do a renv restore. Again, renv is a package that lets you replicate your environments. So you can, for example, avoid the error of it works on my machine. And that is something that most of us programmers kind of face all the time, or we cause it in a lot of cases. But then renv lets you avoid that altogether. So what you can do is you can do a renv restore here, and it will install a few packages that are required for this. It should not take a long time, hopefully, as I can see that there's some sort of error on mine. So let's hope it works. Yeah, okay, there is an error. So I hope the restore steps goes well for you. If not, let us know. And I'll probably just go to a project that I had set up ahead of time. And this is how you would experience the different art shows where they already have something made. But of course, we'll not leave you hanging. If you have any problems in setting up, we'll help you out. And I think Pavel is already in the chat, and I'll be around too. So if you are able to open that first project and do a rent-free store, let us know. If not, let us know as well. And I think this is the most friction, the most friction, the part of this workshop that has the most friction. Sorry for that fumble there. And I think once we're through this step, we will be able to restore most of the things or run most of the things. I'll probably give another 5 or 10 minutes, maybe, just to see that things are working just fine and you're able to get into that project. And there's at least no major issue. Okay. Yeah, I think it'll take some time to download the environment. Fantastic. Thank you for letting us know. I think we can follow the same spirit as Ulrich here and just share if things work as well. So possibly a 200 in the spirit of our our session. We could do 200 if things are working fine, and then we can move forward. Okay, so you have that's great. If you have the project open, Christy, you can run restore. That's a that's the function, and then it should just install the environment for you. Yeah, fantastic. I can do that again. So let's go. Let's close this project entirely. And there are multiple ways to load an environment into our studio. So one is that we do it directly from GitHub. Another is that if you already have downloaded a zip or downloaded the code, maybe Git cloned it, you can actually just go into open project. So I'll first do the new project and then I'll do open project as well. So if I do new project, I just go into version control, I go into Git, and then I paste that URL. So if I do that, I will be able to fetch the entire repository, and then it will create a new RStudio project. If you've already done that, maybe from terminal, maybe you've downloaded a zip, what you need to do is you can do open project. And then in this case, for example, I have the project right here. And then you can either open this whole directory or you can open this one. So if you browse till here, you can just open Plumber Basics. It should get you to the right project. Okay, there seems to be an error on an LME, a package. Let me let me see if we can make sense of that. I think it's trying to make the package instead of downloading a binary. Okay, I think we have a mixed response here that I was able to find the G Fortran. Okay, so P3M. P3M had an error. That's just a package manager for getting binaries that I use, but I think if it downloaded from CRAN, it should be fine. Can you please ensure that you're on the right version of R, which should be 4.4.3 in this case for this workshop? Okay, I think we can. Yeah, I think that's probably the issue. We did try to share the requirements a bit earlier in an email as well. I think that's no problem at all. But I think that's why the rend restore fails, because it expects the R version and the Rlang version to be on a specific version of R, which will get all the other dependencies. So I think what you can, yeah. So if you don't have Git downloaded, I think that's a question we can take. But before that, for Harshan, I think what you can do is, and what I'd recommend to anyone who is unable to set it up just now, you can follow along with the workshop, and I'll be available anyway to answer any questions that you have further along on LinkedIn, or you can contact me directly on email. And as Pavel said, Justina, you should be able to get the zip and then follow the same process to open a new project, and then select the Plumber Basics directory from the main directory. So for anyone, again, who is unable to get the environment to restore, feel free to follow along with the workshop, and then try that code out in your own time, in your own moment, when you can figure things out, and then you should be able to at least make some sense of it, because you can take it just as a webinar in the sense, and then try to not follow along as much. And that said, again, just to put you at ease, most of the code here uh, is available on GitHub, and most of it will be just code samples, so you can always run that. And I see a question from Andy as well. So Andy, the way rent restore works is that it will work for project by project basis. More context to I'm going to give you more context on that. So there's this file called rent.log, and if you have this file, you see that it's only local to the project. And each project, when you do a rent snapshot, it creates that rent.log file. And if you do a rent restore, it lets you open that. So it works on a project by project basis. And I think most people are set up. And again, if you are not set up, do not be disheartened. Feel free to reach out at any time when you're able to run the code. And I think in the spirit of time, we will move forward with this first section. So just to double check, ensure that you have the Plumber Basics project loaded, and then we can begin. And as Pavel said, this is one of the most classic error. This is R trying to compile a package instead of trying to just fetch the binary. And this happens to all of us. Most of the time, this happens because of different versions, but then this can happen for other reasons as well. So again, do not be disheartened. Feel free to reach out whenever you want, and just follow along as a webinar. So this is what programming is about, and this is what live coding is about. Things will mostly never work when you're live. So I think we we know that as programmers. And I hope I have restored my rent, because if not, then that would be another. Yeah, okay. So hopefully that works for me. Yeah, I think it's going to error out for me as well for some reason. I hope not. Yeah. So as you can see, I'm facing that error as well. What we can try is do a simple run install and see if that works, because if not, then we'll have to see how to go about this. Yeah, okay, so I had the packages cached, and what you just saw is that all the packages were cached somewhere in another project. And this is why Ren is also good, because Ren tries to fetch the packages only if they're not available in your computer somewhere, and then if not, then it just brings the packages from the local area. And for some reason, I still don't have this package. Yeah, okay, that works. And yes, if we could highlight that message, that would be wonderful. Do not be disheartened. All of this happens. So now let's go on to the workshop after that chaos that just ensued with my machine as well. As you can see, rem restore fails. So we'll not worry about that. We'll just try to see this analysis script. And now to go back into the flow of things, most of us have created an analysis script at some point in our life. It's just some tidy words wrangling, some data set that we have. And just to give you context, this flights data set is just the standard data set in this package, NYC flights 13. This is what we'll be using for most of our examples. And what we've done here is we've just taken the long flights, and then from the long flights we've created some sort of delay summary. And I think that didn't work again, so we'll just load the package. And if you see this long flights here, it's just a filter from dplyr, and then we'll do something to it. We'll wrangle a lot of data, and then what we're just doing is we're creating a delay summary of averages, and then we'll see how that works out. So now we have average delay by carrier, and then this is just a small analysis. We've all made a script like this before. So the first thing that you need to do to get to Plumber is make a function. And if we go to file number 2, we can see this comment: find everything you can ask a user for, and then that's a parameter. So this is a really good way to think about APIs. This is a really good way to think about functions. And the good thing about Plumber is that if you've gone to a function already, you're halfway through. So you're halfway already there. You know that min distance is something that the user would need to enter. You know that you can probably set a default value here of 500. And that's how we'll create this function. So if you notice this file and this file, it's mostly just converting it into a function. And now we have this flights data here as well. And we have this function. So let's try and put that function into our memory. And hopefully it works with 1000 as well. And if you see, we have some sort of function that returns analysis. So what if I told you you already have an API now? And that would maybe be a bit too ambitious, but then that's how things work. If you go to file number 3, basic API, this is all you need to make a Plumber API initially, at least not if you go into the advanced topics of parameters, advanced topics of authentication, of different hooks, different things as well. So this is all you need. You need library Plumber. These are some decorative tags. If you're familiar with our oxygen, this will appear very familiar to you. Only that you have an asterisk instead of a single quote. And of course, Plumber as well works with the single quote as also, but using an asterisk just separates it from the rest of the things. So if you open this third file, you see that there's this at get here, and this is how Plumber works. So if I were to, let's say, create another function, and thank you Copilot right there. So Copilot is going to help us out here, and we see that we have a get function with a get random, and let's see how far it takes us. So okay, that's very enthusiastic of it. And if we just do that, we have another endpoint now. So what this get is that it's a decorator, and you see here one is for post, one is for put, you have one for delete as well. So once you do that, let's say get, this is the path. This is what will be followed by that link to get that information. If you go back to our example with the cats, this is the fact bit, if you remember that. So this is the fact bit. If you misspell it, and if the user misspells it, it's a 404. Sorry for that. So we'll just remove that and get that out of the way, and we'll run the API. And you probably can't see the browser window because I'm only sharing our studio here. but I'll stop sharing once and share that entire screen. So hopefully we are able to get that to work. Okay. And yeah, so we have this basic API, which I still can't drag back into my Chrome. Sorry for the jumping around of tabs as well. And I'm unable to push that into the iPad for some reason. So that's another oops for me. And here we have that. So the Run API button is created automatically by RStudio. If you're familiar with Quarto, if you're familiar with Shiny, RStudio detects that it is a Plumber project, and that's created automatically, which is why I think RStudio was my more recommended option here. You can, of course, do Plumber Run. Sorry for that. If you do a PR run, it will do the same thing. But RStudio kind of maps that into it for you. You can also run the API in the viewer pane to see it right in the RStudio window. And I think it didn't work because I already have that running here. So I'll just turn that out and then run that into the viewer pane and run API. So if you don't want to go to another browser window, like I just kind of fumbled around with, you can also do open in viewer and then you see the API here. So if you see this, you see that it's a simple web page. And you see that there's the health endpoint here. So what the health endpoint does is it lets you check if the API works. This is the request URL. This is a curl command. This whole UI is called Swagger. And I think we'll open that in another window anyway, just to make more sense of it. So now if you see this health check, which should be in health actually, so you see this URL and you see a response. The response says status okay, and it gives you a code of 200. This means that the API has worked perfectly. You've hit the endpoint, you've gotten a health check, and it's always a good idea to include a health check in your APIs because that is how a polling server can know that the API does work and that's something that they're doing. Something is wrong with what they're doing, maybe a wrong parameter, maybe with some sort of VPN, some sort of different access that it's not working. But an API exists, and this is how we check it. So essentially, if you are able to just follow along with this code, which is library plumber, and if you follow along with this decorated string, you should be able to get this to work. Now, a few notes on what this API title, API description, API tag does. So if you run this again, you'll see that the health comes in the default instead of the health check tag. So what creates this health check is actually this API tag, and the syntax is simply API tag, some name. So let's call it some name, and let's call it lorem ipsum. So what this will do is this will create another tag here, another header that your API can be divided in. And why this works is, and the reason you should do this more often is for better documentation. So if you see here, most of the documentation does get filled for you by Plumber, and most of it does make sense to the user, but it does make a lot of sense if you have a very large API to show the user where some endpoints are. And we'll see this in action as well. But let's say you wanted to move this health into the health tag or health subheader. All you would do here is a hashtag, a star, uh, just do a tag, and then you would do health. So if you do this, and if you run it again, you'll see that the health appears in the health check heading. And this is actually a basic API. This is mostly everything that needs to work. And now all we need to do is add more functions to it. So I think in less than, I would say, 15 minutes, we are able to create an API with Plumber. And this is what I like about it. And of course, the Run API button automatically appears, which is great as well. And RStudio is really good because it lets us publish it directly to Post Connect as well as some other places. But we'll not get into that until the end. If we have some time, we can discuss deployment as well. So if we go now to file number 4, that is functions to API, you see that it is more or less the same file as we just had. but we now have a function here. So what we do is we first have a simple description that shows up in the Plumber documentation. Then we have a param decorator. If you're familiar with R oxygen strings, if you've written package documentation before, you know that this R param exists in Roxygen as well. And we just describe it as we would in Roxygen. So we do param min distance, minimum flight distance, default is 500. And then we do get delay summary and a tag of analysis. Now the function part is interesting because we'll see different forms of it through the workshop, but we have this function which defines this 500. So just writing it merely here is not what works. What works is that you assign a value to it. And this as numeric, you may be curious here for why we have an as numeric, because essentially if you were to write a function, you would mostly get away with not using it here. But the reason we need this here is that when you try to access the API through, let's say, some sort of library like HTTR2 or some sort of software or some sort of web application, what you essentially get is a huge string which looks somewhat like this. So again, it looks something like link.com slash, in this case, delay summary. And then you have some sort of parameter, and then you have another parameter. And this is how usually get APIs work. So what the browser gets, or what the API server gets, is a string here. And it's really important to parse it out. I also recommend using something like Checkmate, which is a package, which is of course not installed in our environment right now. But what Checkmate lets you do is put hard checks onto our variables in R. And I would recommend using that for functions, for APIs, for all sorts of places in general, because Checkmate is a really, really nifty package. If you know that R is dynamically typed and you kind of sometimes need strict typing if you are ever building a system that real people need to use. And I think Pavel will agree with me here that you need some sort of assertion, some sort of checking of if that's actually a number. And this is why we need it here, because otherwise that min distance is a string of 500. So without further ado, let's try to run that. And if we run that, you'll see that you have this description. If you see, it's right here. You have a title here, and then you have a health heading and an analysis heading. And if we go back into our analysis, for some reason the window won't scroll down. Yeah, so now we have that. We have average delay per carrier. Try it out. And the reason these docs work is that this is mostly Swagger. If you see this word here, Swagger is a mostly open source standard that you'll see most API docs in. Of course, there are more fancier ones, more, I would say, more aesthetic ones. There are some that are native to Python, if I remember correctly, and Fast API. But Swagger works pretty niftily out of the box. You see the documentation, you see that there's a strict typing here, you see that this is a query, you see the description, and then you can do an execute. And if you see here, you see that you get some sort of response. So this is the same data that we would have gotten from this function, only now that we get that in a JSON format. But this is just this preview. How about we copy this URL? And since this is a get API, we could open up a new tab and okay, so we can open up a new tab in Chrome and then enter that URL. And if you see here, we get the same response in the browser. So the way this works is that you change the parameter here, let's say 1000, and you get a new data set. And this is JSON. This is something that you can use in any web application. And this is, again, one of my reasons for using Plumber, because R has a lot of advantages. I think data wrangling and data processing is one of the most important advantages of R that I really, really, really use on a day-to-day basis. But sometimes you just need it for the analysis, and someone needs to consume this data. So if someone needs to consume this data, you could create an API that just gives them the data in how their application would prefer it. And JSON is a really good handshake of different web technologies. And this works almost perfectly out of the box. Let's try to misspell a parameter now. So if we just do min distance, that worked. That should not have worked. And now that's still working. And that's probably because R tries to match different function parameters. So if I try to do max distance, let's see if that works. Okay, that should not be working, and I'm really not sure why that should not be working. So maybe you can try the network call, and this is completely off script now. So I don't think the API should do a max distance, but it is working here. So maybe this is something that I have not been using correctly, or maybe I'm not familiar with this as well. So if Pavel, you have some thoughts on this, I would be happy, because right now this is a gotcha for me. And I think this is a gotcha for everyone. And I would want to explore this further. So without that, without going too deep into that, yeah, probably because it's sending a default. That's right. Okay, that's a really good explanation, and I think that works. Because what's happening here is if you do max distance 1,000 and there's a default of 500 set, it will try to fetch the same data. So let's try to do a min distance of 500 and see if the data changes. Nothing. So I think this is why we have Pavel here, and that's my word to him. Thank you so much for being there, being around, and I think this is a perfect explanation. So since we've set up a default here, it is a 500, and that somehow just the API just somehow calculates it. If we go back here, and if we just remove it entirely and do a reload API, or maybe a run API back again, and if we go back to the browser window, I think it might fail. Yes, so it's an internal server error. Thank you so much for that. And is Swagger installed? I think Pavel has already answered the question. It comes with the Plumber package or any API library. If you are familiar with Python, you use Fast API. Fast API also brings up Swagger, but you are also able to use other API doc templates in that. So again, let's go back to our studio. And now that we've cleared that gotcha live on camera, so we'll not be disheartened and we'll move forward to something that has all the functions. And we'll not save that. And now we have this file with every single function. And then we have a final API. So the way this final API works is that it will source something called analysis.r, which is pretty much exactly this file. Okay, so the one sentence reason is that we had a default parameter. So if we go back to this file, if we go here and add a 500, the API just ignores the parameter entirely. So if you have an error, it will ignore it as an erroneous parameter and then try to use that 500. So we have that down, and now let's try to this file number 5 is just for reference. It's mostly that we have all the functions, and what this last file, the final API, tries to do is it tries to source this file called analysis.r. We can also change that to the 05 all functions, and you'll see that there's an entire API now of all the different functions. And now I want to talk about not just analysis, but plotting. And if you've ever used RShiny before, you know that RShiny tends to kind of wait around if a plot is being generated. And that's one of my, I would say, most important frustrations or most unique frustrations that I have with Shiny, that once a plot is generating, it gets very difficult to generate it back. So if we go back into that function and we see in analysis.r, this plotting function, we use the eCharts library and we create a plot. So let's just try to source this entire file and just try to run that function once and see what happens. So if you do plot daily volume, it needs an origin airport. So let's say I try to add New Delhi, and we see a plot here that's built in eCharts. So most plots and most plotting libraries are HTML widgets. And HTML widgets are how Shiny renders things on the fly. So what you can do with Plumber actually is generate a plot on the fly. And you don't need to do anything else. You don't need to have a lot of code in the background. So if we run this API, And if we go to this plot daily volume, and we do this parameter again, we see this great amount of HTML that kind of thrown up out for us. And if we copy that URL and if we open up a new tab here, you'll see that the plot renders without any R code behind it in a way. So you don't need to do anything. As long as the API is functional and it's working, you can run it in a browser and you will get a plot. So this is, I think, the neatest way to share any sort of plotting, at least non-trivial, at least some sort of trivial plotting, and even some non-trivial cases, because you are able to abstract out all the logic and you are able to share just the result. And Shiny can then render this with the friendly functions of HTML widgets. And I think this is one of my favorite and most powerful features of Plumber, because once you are able to do this, you're kind of able to achieve an app that just does the processing on the fly. What you are essentially doing here is take away the processing from the app, and you are able to just move it into a different server. So in theory, your app makes 4 plots. You have a server that has the API running. The server has a load balancer. You get all 4 plots instantly. And all you need to do is just send the correct request. So we'll see how to send the requests in further sections as well. But before that, we'll probably take a short break right here. And if you have any questions, if you want to just go grab a water, if you want to grab a coffee, feel free to do so. Again, thank you for bearing with the technicalities here. There's a lot of things that can go wrong in a live demo, and a patient audience is always helpful. And in lieu of patience, I think there's also encouragement here. So that's, again, wonderful to see. Thank you so much for sticking around so far. And thank you, Pavel, for all the help. I'll take a break as well. I'll get a glass of water. You're free to take a break as well. Please feel free to leave any questions that you have in the chat, and we'll address them right after the break. So I think we'll take 10 minutes and come back. Okay, so I'm back, and I think we can take some questions and then maybe get into how to modify an API, and we'll try to change a theme for the plot in that example. And after that, we'll go into some of the advanced concepts like authentication. But there's a poll ahead of time. Are you able to follow along so far? So we'll just look at the responses in a bit. If you are not able to follow along, or if you're somewhat able to follow along, that's fine. You should not be disheartened, as is the theme of this chat so far. And I'm really excited to continue the rest of the workshop. So I'll just try to share the other screen once again, put it up on the stage, and see if everything is working fine. And I think it's working fine. So now I think we can take a few questions. So I think, and please forgive me if I mispronounce your name. I'll do my best to not do that. And if I do, again, I am really sorry. So I think Jupril Adebayo says, are the APIs deployed for free? In my experience throughout the last couple of years, yes and no. So the no is that at some point you do have to start paying for it in a way, because otherwise there may be some pitfalls. For example, there would be situations and scenarios where the API just doesn't respond, and free services tend to do that. They tend to do a cold start. So what a cold start is that when the first request comes along, the deployment server or the service knows that, okay, this API needs to be activated again, and then they'll activate it. So it'll take some time for the first one. And a good example of this is, and I'll leave it in the chat, is Render, and we'll talk about that as well. Render is something that I currently use. Render allows for free as well as paid deployments for APIs. And if you notice the files here, and if you go one directory up, you'll see Docker file example. The reason this is here is that this is just to show you a template of how you can use a Docker file, which is, again, a separate topic altogether, Docker, how you can use that to deploy APIs anywhere on any server. But as Pavel already said, as a reply to Chupril, that the Plumber specific deployment usually works best on PostConnect, Connect, but it's a paid software. And on shinyapps.io, in my experience, I was unable to get that to work. So I don't think that's really worth going down into that. So the few options I'll leave down in the comments for everyone. For deployment, I think there are a few options. One is Amazon EC2. Uh, then there's Render. Then there's also something called PM2, which works on a Linux server, which is an NPM deployment environment, or I think tool. I think a tool is a better word. So I've tried these three. Out of them, I think PM2 can run anywhere. EC2 is a server that you would again use, but then Render is something that works for free, at least out of the box. So if you use that Docker file, and we'll talk about that maybe towards the end if we have some time, you should be able to get things up on Render. And I think that's one of the best ways to get started with at least checking how deployments work in Plumber. I think Christie's query was already solved. There was a typo. I think it happens to all of us. So we can move on to Brinda's question, which is interested in knowing how to use Plumber APIs in my already existing Shiny apps. So I think it goes two ways. You can always create an API for yourself, but that depends on how your Shiny app is written in the first place. So if you have, for example, if you've already abstracted out the logic for a lot of functions, you kind of can follow the same suit that we just did, and you should be able to at least bring the functions together into an API. That works really well. That works really out of the box. But if you've not done that, and if your Shiny app is too tied, you might have to first abstract out the logic. So again, Plumber is just a way to expose all of your functions to really quickly create an API. And you need functions for that. You need functions that work independently without any, maybe some sort of data that it needs should always be available. So everything in the function should be available. The function should be atomic, as we see in this case. Even though we use a separate helper function, both of these are atomic functions, so they are able to get the plot. And I think that's the beginning of it. The second thing is, again, as we discussed already, deployment. You need the Plumber to exist somewhere to use it in the Shiny app. And once you cross that bridge, then it's just a matter of using HTTR2 to get the API or run the API. So we'll also have another example, as you can see here, for HTTR2 and Plumber. So at least that will set you up in some direction for Shiny apps, but not entirely. Again, I am open to answering any questions that you can send via email. My email is already in the GitHub repository. If you see the README, you can see a contact here, and you can see a LinkedIn link as well as my email. So you should be able to at least get some of your questions answered. And I think Alvaro, my good friend, has a really good question. So for Plumber utils, I have been able to do that before. I can share some sort of example because that's again open source, although it comes from a separate project. So let me just quickly pull up my own GitHub, and there should be this API, and I'll leave this link in the comment as well. So if you check this branch, which is my own branch that I use and that is completely open source, every function, every subset of the API has a utils file, and then I use Box along with Plumber to use all of these. So if you see here, the utils are imported along with that. So that does work, but then it's not that neat because no matter what you do, the Plumber does get long. And I think that's one of the, I would say, pitfalls, because the more documentation or oxygen strings you write, the longer the Plumber file will get, and Plumber requires them to just be run. So again, I'll try to leave that link down there, and hopefully that answers your first question, Alvaro. I see you have a second one as well, but before that, I think we can answer Jacob's question. If a plot or other object is called by API, can it still interact reactively with other parts of Shiny? Short answer, no. I think Pavel has already replied to that. Uh, Again, if you want to play around with JS, you can kind of do that. You can drag drop on the plot and make Shiny work in a certain way. But I think the better thing is at least one-way reactivity, as Pavel said. So one-way reactivity is that you can change the plot from your Shiny app, and that's reactivity for you. But then if you really wanted things to work, you could use JavaScript to uh, to make the plot change other things in your Shiny app. But since this is a separate object entirely, there's no way around it except using JavaScript. So if you want to do that, you can try it out. But then again, I would say the use case is different. So the use case is to, at least in this case, is to abstract the plotting functionality out of the Shiny app, as well as the resources that the app uses to make the plot. And the other use case is to build a complex interaction. So maybe you can pick and choose your battles. You choose the plots that need to be fast, and then you choose the plots that need to interact with the other plots. And you kind of do some with Plumber, you do some with Shiny, and I think that will be a really, really good combination of functionality. To Alvaro's second question, I've not yet tried Plumber 2, but my eyes are on it. I am waiting for them to at least uh, build a bit more there. But I'm definitely watching forward for it, because I think they wrote something really cool in the package description. They wrote that they're taking all the mistakes that they made, and now they're trying to not make them, and they're trying to do a complete rewrite. And I think that always leads to good things. And because I think this is how HTTR2 was also developed, and it kind of fixed a lot of things that HTTR had a lot of problems with. So I think that's something that my eyes are peeled for sure. And I think Charles has a question. Yeah, so that's eCharts for R. eCharts is a visualization library that is a JavaScript package, and there's a wrapper on it by John Cohen. And then there's another library that I really enjoy, and I'll leave that in the thread for Charles. It's HighCharter. So HighCharter is another plotting library that works really fluidly, creates really beautiful plots. The only thing is that HighCharter has a license. So if you use HighCharter, it would be you would need the license at some point. So especially if you're doing something commercially. But then if you're, I think, using it for personal use, HighCharter is again a really, really good library to use. But my eyes are set on eCharts. I think eCharts is the neatest plotting library that I've used so far in Shiny, and it kind of does a lot of things out of the box that you would otherwise need to kind of do a lot of jumping around hoops in, let's say, Plotly or ggplotly while creating a ggplot. So now that we are on the topic for e-charts, I think Leslie has a really good tip for NLME. So just bumping that up, in case other people do want to follow suit, you can try that tip out. And now coming to eCharts and the workshop again, let's try to do something. Let's try to modify an API. And what we'll do is we'll add a new parameter. And let's say we want to customize the theme of this plot on the fly. So assuming that you want to give your plot to different teams, and assuming that all the teams have their own design language that they like to follow, or at least they want to get the plot in some colors that they really that fit really well. So what you can do is, let's say we change this e theme here, and if that's a bit zoomed out, let's do that. So we can actually add a parameter called theme here, and let's just do e theme once to see if there are any available values. So we see that there are some existing themes that we can use for e-charts. And what we'll do is we'll just add another param. And for default, let's say we just do vintage. Okay, so what we'll do now is we've now modified the function, but we need to modify the API as well. So if you just modify the function, it will not work. You will need to modify the API. And what we'll do here is, I think that zoom out is a bit worth it here because there's a lot of text. So if we do a param theme, and then the eCharts theme to use, let's say. So we now have a param here, and then again for theme, and then we do vintage as a default. And inside of that function, we pass um, theme equals to theme. So hopefully it all works well. And let's run the API. So if we do that plot once again, you see that vintage gets autofilled. And let's do del, and let's copy that URL because right now we can't view the HTML here, so we need to go to another tab. And let's put that into a new tab. And you see that the theme changes immediately. So again, it's as simple as putting a new parameter in a function and then adding it to the documentation. What happens if I don't put a theme? It goes back to vintage. And let's say I do theme equals to Walden, the theme changes immediately. So again, this is just to illustrate that it's as easy as modifying a function, and then you just change something in the Plumber documentation or Oxygen string decorators, and you can create as many params as you want. And this works really well and really quickly, as you just saw. So now I think we're kind of done with the basics of Plumber. And now we're kind of going to go into somewhat more advanced ideas. So we'll close this project out and we'll open the second section of this workshop, which is Plumber with authentication. And this is a more bare bones API and example here. So we'll probably not do a whole API with plotting and everything else, but you will see that authentication is something that you really need, especially if you're working in an actual real life use case, because if you don't have authentication, this is deployed somewhere, this would be accessible from anywhere. And if let's say the address is your company or something, and then you just have that API deployed somewhere, anybody has access to your data. So you don't want that. I mean, in the best case scenario, you don't want that. So let's just try a run restore in the new project. And let's just see if we are able to load all the dependencies. Okay, so it still doesn't let me restore my renv, so I'll just do a renv install. And again, a show of thumbs up in the chat would be great if we are able to set up or at least run the second project. So now if I do libraries, I'm able to use the libraries. We'll wait for, I think, a couple of minutes to see if everyone is able to set up and get into the second project. Again, that's 02 Plumber with authentication. You can also click the rproj file in your file manager and file explorer to just access this. Perfect. Can you try to load the dependencies.r just in case we know that the packages work? If they don't work, then we just do a rem install. And what rem install does is that it tries to find all the library calls in your project, and it tries to install all those packages anyway. Great. I think it's working. This is good to know now because I think we hit a snag in the beginning. But again, I would say that's expected, and we're still doing fine, at least both on time as well as what we do want to cover in this workshop. For authentication, I think what I want to give you is not the logic more or less of how it works. Of course, we'll talk about that. But what I want to leave you with is just a literal placeholder example that you can plug and play. Actually, the way I set up this entire, I would say, demo or the all the three projects is that you can actually pick that code out and you can use that in your projects. So that you have some sort of example. And you can kind of literally just yank this auth helper and use it, but we'll talk about that later. Um, let's try to make sense of this little project. We have a plumber.r. It sources three files for us. Again, not the most ideal way to do this. I would recommend using a package called Box that I just talked about. Box is, I think, godsend in some ways and also a pain in the other ways, but it does help in structuring code and moving things a bit around and make things a bit easier. So again, we have this very small API which has just one function and one health function. This is the first example that we saw in the beginning. But if you notice, we have this little thing called auth helper here, and these two parameters of res and req. So these are reserved parameters that Plumber uses. I think Hassan, you have a question for the tutorial. Just to double check, is it about the authentication or is it about the first section that we just covered? If you missed the beginning of the workshop, you can just kind of go to Plumber Basics and try to run these step by step and kind of explore around. And I think you would be able to find your way. If you mean the auth helper, we will still cover it. So we're yet to cover that. And moving back into how this works. So this, I would say, model or structure. Yeah, so for this first section, I would recommend going through the code. It's already in the GitHub. If we could pin that again, or maybe I can just share that once again in the chat for anyone who missed. Here are the slides and here is the GitHub. If you are able to get the GitHub, you can also get a zip file and then start using the code. So I would recommend if you have missed the first section, go through this in your own time, and then the other parts will make a bit more sense. Okay. I think there's a package issue as well from Christy. I think this is again one of those Renv issues. Although we will not go too deep into the code here, so I think you should be fine with just following along. I think that should be fine because we're just going to discuss a couple of functions and we're going to see how they work together in the context of Plumber. So to share this model, we have this Plumber, we have entry point, and we have auth helper. Auth helper can also live in the plumber.r, but having it as a separate file also works really well. And a key package that we'll use here is called useThis. And what useThis does is that it gives you a lot of different helper functions to change configuration parameters and other things. So here we'll do edit r-environ, which is the r-environ file. You can also just go ahead and create a blank text file with the name .r-environ. And of course, this is a plain text workshop key for the purpose of this workshop. I would not recommend having an API key that literally looks like this. In the best practices, your API key should be encrypted, hashed. It should not be as simply decipherable as ShinyConf 2025. But what we need to do is just to try things out. We do useThis, we do edit r-environ, and then we change the scope to project, and it will open up that same file if you see. So again, use this as just a simple helper package. I recommend using it because it lets you do a lot of other powerful stuff, and just exploring it and finding your way around it can be really beneficial for, I would say, most of your workflows, not just Plumber, actually R packages, apps, and so many other things. The thing about the R environ file is that each time you make a change, you need to restart your session in R from session. So since we did not make a change, we'll not do that. But again, it use this kind of gives you this tip as well. So if you forget it, again, use this is going to help you out here. So the way this works is that the Plumber API will have a helper function, and we'll try to write out that helper function with this add auth. So if you, sorry, just a second. If you see this auth helper, what it does is it takes two parameters, the response and the request from Plumber. These are again reserved keywords. It takes a function. This is just the standard capital FUN notation that you will see in a lot of our packages. And it takes a dot list. The dot list is, I think, a packing or unpacking mechanism, which I really like about R. So you can pass this dot list into a function, and the function will be able to kind of just make sense of it. So what we essentially send from this, if you notice this syntax, and again, if you don't follow this really easily right now, this is literally just for your own use, and you can use it out immediately out of this app, out of this project. But to give you more context on how this works, if you look at this auth helper, we have the response and the request. These are for Plumber. We have a function name. So again, this is not the function being called. The function would be called like this, but we don't put the parentheses, so we just pass the function. And if you just print it out here, you'll see that this is just the function that R is passing into the auth helper. So what we do here is whenever someone hits this endpoint, delay summary, it goes into the auth helper. It passes this entire function definition. And along with that, it passes any named parameters. When I say named parameters, in this case, it's just one. It's min distance. And it says it does the same thing as our previous project, only it passes it into the auth helper. And now this auth helper is just going to take this code and kind of check some things out. So what it does check is if something called HTTPX workshop key is in names of request. So when Plumber creates a request, it has names inside it. Like it has a list of things inside it. And this names will come from there. So what we can do here is we can do a browser, and then we can run the API to see things in action. And let's say we go here, we execute the API. Now we're here into the browser. And let's check what the REQ is. And it's an environment. And let's do a names REQ. And you see all these names here. So these names are, again, things that Plumber creates to make your request an actual HTTP request. So what we're doing is we're just checking, is HTTP workshop key inside of request? And it says, no, it isn't. So request does not have key. Why is there no key? Because we did not fill this little authorize block here. So if you notice, this wasn't present earlier. The only reason it is present is because we've done something here with the add auth, but we'll talk about that a bit later because again, that's just a function you can yank out and use. Now we'll go on to the next condition. So if we see this workshop key is not present, the next condition is if it is actually present, is it equal to the environment variable of workshop key? And we just set that in the R environ, and that's sysgetEnv. These are two helper functions from R. If you've written scripts before, you might have encountered them. If not, we'll not worry about these. These are setEnv and getEnv. And we just, if you do this, for example, with a typo, it doesn't work. Without the typo, it does work. It can fetch any data from your R environ file. So the next thing is does is, if it does exist, is it valid? Or is the environment not set at all? So what that checks is, does the workshop key actually exist? And if we do a character count of this, again, this variable, it does exist. And if we were again to do this, it won't exist. So this condition, these are three, I would say, conditions that check if the request doesn't have a key, or if the key is not valid, or if the environment is not set. Return unauthorized, or with a code of 401 and a message of this. So again, going back to what the Plumber reserved keywords, we had the request and now we have the response. The response has a body. We're modifying the body manually and we're modifying the status of the body manually. So if we just continue that browser out, and if we go back to the API, it will tell us missing or invalid API key or invalid configuration. So it gave us all three errors. It gave us maybe you've not added an API key, maybe it's invalid, maybe it's an invalid configuration, and it gives a 401 code, which is unauthorized. So this, and you can see that the key is workshop key. Again, this is just one way to do this, and this is probably the simplest way. There might be more ways to do this, but again, this somewhat works. Now what we do is we go back here, and in this, we add ShinyConf 2025 and we authorize and we close that out and we do an execute. Now we're back into the browser because we put that there. So let's continue here. And now we get the data. So if you see, you can kind of authenticate the API. And now if you check it with the browser, I think it's again triggering that browser out. It says missing or invalid key or configuration. So you get that error in the browser and that's printed out for you. This is in contrast to the previous APIs that we made because they were able to get that min distance for you. So now we have some sort of authentication, and now we just can't access that with the browser. So now we need to make a proper request with proper authentication, and only then are we able to access this API. So again, this is something that we'll visit in the HTTR2 section of how to actually get that authentication done. But to go into that last file of entry point. So this, all it does is this add auth is taking the different Plumber requests and it's kind of just adding a requirement for X workshop key into all of these requests. So if you see that there's no patch here, if you were to run a patch request in this case, it would pass. So we're just kind of doing a simple helper function here, and then we are doing a bit of Plumber code here and adding headers to the Plumber. Again, what the headers are is that headers are specific, as we discussed in the presentation, headers are specific metadata. Here, the Plumber API that we've just created has a pre-route or pre-check of these headers being existed. And then it kind of works if the API key is present for all of these different requests. So this is just to show you how you can add authentication. And I would not expect you to kind of understand every single piece of this code, because if you see these PR prefix functions, these are Plumber specific functions. And this is yet another way to create a Plumber API. So if you were able to just source this entry point, the API would still run. And this is mostly about authentication and adding it. And still, I would say this is again not an example that I would expect you to completely understand right now, because again, this is changing a lot of things in how the inner workings of Plumber work. And I think Alvaro mentioned that Plumber 2 is about to be out, and it might happen that Plumber 2 doesn't work with this logic. So we might have to add another way, or maybe they kind of make your life easier with adding authentication to the API. So this is kind of just a quick example of why you need authentication in your API, because you won't want anyone to access any of your data from a simple browser, as well as you can then try to add more configuration. But then you would think that the environment variable is just set here, and I can change it at each time. So in an actual deployment scenario, you would have this added onto your server. So this renviron would exist on the server, and the request that is being made would be checked against that. So in that case, this lives somewhere else, and whatever is making the request will live somewhere else. I know that there might be a lot of questions here, so maybe you can put out some of these questions and we can see if they're in the scope and try to answer them. What I would recommend is you to just try this out as well and try to see if you are able to get this logic to work. Again, the entry point is just a way to modify the existing Plumber functionality and that you get out of the box. And the auth helper is a way to integrate this authentication into your Plumber. What I also do is if I was to open the project that I just showed on the screen earlier, what I also do is that I kind of improve that with a cache helper as well. So if you see this cache helper, there are different helper functions that you can kind of wrap your Plumber around. So the cache helper lets me also cache some of the data, and then there are other more optimizations that you can add. This is just to show that the Plumber API is a starting point. You can start to modify it as for your own use cases. You can add functions over functions over functions. You can add an authentication function. You can add a cache function. You can add memorization, which is a technique again to cache data or responses. So this is more of an advanced section of this workshop. So we'll kind of wait for a second if there are any questions, and then move on to the last part, which is accessing this API using HTTR2. So now what I'll do is I'll open a project in a new session, and there's a reason for that. I'll open the HTTR in Plumber, but I need this API, the second API, to run as well. Yeah, that takes a long time for me to load sometimes. I'm not sure why that is, but that does happen from time to time. So for this section, we can do a rend restore or a rend install again. Mostly, I think the restore should be fine. And now we have these three libraries, HTTR, JSONLite, and use this. For some reason, I think use this is not in my rend float log file. So again, that's an error on me. I think I added it in the end, probably. Yeah. So now that we have these three packages and we are able to load them, we can move on to accessing the API using HTTR2. But we also have some time for some questions. And the way I think I would like the session to flow is that if we are able to cover this section really quickly, we can discuss some deployment options. I can show an existing deployment that I have or go into the Docker file. And I can also bring Pavel on stage to discuss some of his thoughts on how APIs and Plumber work in R. And meanwhile, we could keep taking questions if they come up on the chat now and then. So if you are ready with two of these projects, do leave a thumbs up in the chat. So that is the second project and the third one, which is the HTTR2 and Plumber. Yeah, I think there's a really good question from Venkat, and I would say that this is exactly why I want to touch upon authentication. Uh, if you deploy it on any server that has the authentication, that has some sort of authentication that you put into the Plumber API, and if you don't put a plain text API key like I did, for example, in this demo, which is ShinyConf 2025, you would probably encrypt it, and then that API key would be shared securely using some sort of password sharing tool like 1Password. You have a secure API anyway. You can also use RStudio Connect or Post Connect. That's still a habit that hasn't gone away. It's Post Connect now, and if you use Post Connect, that works. But then if you see an API on, let's say, deployed on Render or EC2, I think in my experience, I found great profit in creating this authentication measure that I just showed. Because if you have a key that's completely protected and a way to decrypt it, it just works perfectly fine. So a step that's omitted here is the encryption of the key and the decryption, but you are able to at least have your data safe in a server, in an API, and there should be no major worries except for leaking of the key or leaking of the hash that you use for decrypting or encrypting the key. So again, this gets a bit deep into, let's say, the security side of things, but there are so many measures to ensure security. The first step is having an API key. And I recommend that even if you're creating an API for personal use, you add some sort of authentication. And this code will at least help you sail that sea, at least to a certain degree. I see a couple of thumbs ups now, so I'm assuming that things are going fine in the setup side of things. So we will now kind of make this API run, the one with the authentication. We'll keep that running. So we'll just do a reload API. And let me just try to run that again for some reason. I think the reload fails. Yeah, so you see this port here and this URL here, 8008. This is really important. So we'll just kind of copy it here, even though we already have the code pre-filled for us. And now we go to the other project, the HTTR2 and Plumber one. And let's go to an API utils function. I'll also take some questions as soon as we cover this side, because this is more or less the smaller side. So what we'll do right now is we'll think of these two RStudio projects or RStudio windows as two different servers. One is our application, the HTTR2 and Plumber is our application, and this is the API server. So there's no real way to simulate this in a local setting like we're doing, but this is a really good, I would say, abstraction for it. One RStudio project is the app, one RStudio project is the server. So as we know that in the server, our API key is set to be this. So we'll now go to the application and we'll write a function. This function is nothing. It gets the API key from my current environment in my application. So again, this is the application. This is where probably your Shiny app or your script will live. And let's try to source this function. I think that didn't copy. Yeah, so if we do this get API key, it says it gives us the key out. And if this variable isn't available, it'll just throw an error. So this is just a helper function. Now there's another function called make endpoint. And the reason I use this, I would say logic, even though this may not be the right way or may not be the best way to do this, is that if you have an API utils and a make endpoint, you can quickly create endpoints that your API can use. For example, in our case, it could be get daily data. So we have, thank you so much for joining, Jacina. I'm sorry that there are some connection problems, but thank you so much for following along so far. So if you see this make endpoint, this is just, again, a creative unpacking of the triple dot, but this can be used, again, to create as many endpoints as available as you would want. So what I have in this renviron file, we have this API path that I've set already, and we have this workshop key. In this case, this is just your local host and 8008. In a real life scenario, it could be, again, your company or something like that. And then that would be your API.your company or something like that. So now we have this make endpoint, and then we have some HTTR2 code. And I really like the HTTR2 package because it's kind of idiomatic in a way. You go step by step like you would for tidyverse. And again, that's not surprising because the same people created. So this process API function, it has an HTTP request, which makes an endpoint. So what we'll do right now is that we'll go into the browser. We'll create a browser here so that we can follow along with the code. And then we'll try to create this process API, and we'll try to run some sort of endpoint. So we'll go back to our endpoint, that's delay summary. So we'll just do delay summary here, and that'll bring us into the function. So now I think that scrolled a bit too up. Yep. So now we have the endpoint, and we have I think the dot 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 will just parse into our parameters. So we have the endpoint, which is delay summary. Let's take it step by step. We'll take this HTTR2 request make endpoint. And again, make endpoint is our function. And you see that this is an object of this class, and we have a request object already. And now what you do is you keep on adding on top of this request object. So now you have a basic request. And what we'll do is we'll pass out a header of X workshop key. And the reason there are hyphens here is that this is the standard syntax, and it kind of gets decoded anyway into the underscores that we have set here. So again, we have this workshop key right here. We are able to get the API key, pass it out, and you see that this request object is now slowly increasing. It had a get and a body, and now it had a get. It has get address. It has some headers, and it has an empty body. And now we have this. Now let's add the request URL query. So for now, the query is empty. We don't have any query here. We can add a query, which is the, again, the min that we were adding in the other place. We'll see that in a minute. And then there's the request performed. So if we perform that request, it says there's a 200 status and that it's in memory. But how do you extract data out of this? That's kind of difficult. So we'll just assign that to, let's say, a temporary variable. Maybe let's call it temp. Again, not recommended. And if we explore this temp, you'll see that it has some things. It has a status code, that's 200. It also has the URL that you sent to. So again, it has every single thing that your response object would have. The good thing about R, Plumber, HTTR2, and all sorts of these libraries working together is that you kind of benefit a lot from the fact that JSON is quickly converted into list. And the way this works is that JSON Lite, the package that's commonly used in R, handles a lot of this conversion in the backend. So you have this object with a lot of lists, with a lot of lists inside it, and then you can kind of access different things. What this last function, REST body JSON, lets you do is convert that to JSON. So now you see you have this object in perfectly parsable R. Maybe not perfect, maybe you have to do some sort of wrangling to get the right data, but then you have all that data that you would otherwise have in a JSON format in a list. So if we were to, again, assign this entire thing into a temp, and if we were to, let's say, check temp again, we have all of these things. If I do a apply or lapply in temp and do a names, you can see that each of our JSON sub keys have the same keys. So if I wanted to, for example, get the seventh one, I'll just do temp 7 and carrier. And I think that should work. And that didn't, because maybe I'm confusing that out, of course, because I've not used this syntax in ages. So I'll probably just not do that. And I think I'll just do, I think that should work. Yes. So I think that's it. So you have it. If you access the seventh element, you can get the carrier. So again, this is just to kind of illustrate what you can do when you fetch the data. Once you are able to fetch the data, you can use your Shiny app to, or use your script, or get that data anywhere in your script, and just use your standard R wrangling to work it out with this. So this is kind of, I think, the overall loop of how we're working with things. Now what I'll do is I'll remove that browser statement, since we have some sort of sense of how this function works. We'll just source that file again. And let's go into the use API demo. So if you see this health endpoint, we still have that out there in the other server. And we have this health API, and we can just kind of hit that endpoint. And it gives us a status of okay, and a 200 of 200 if we were to scan that out. And then if we are going to do this, and again, if we do delay summary, it will still give us some sort of output. And if we do min distance, again, this has to be named because it's being passed into that other list. So you can again use this API utils out of the box. And if you use this process API function, you should be able to at least get the simple HTTR2 wrangling. As long as your output, you want to get it in JSON, you should be able to get that out and use the API as you please. So if you see minimum distance 12,000 doesn't work because there's no data that exists on that filter. So if we do 100, we'll probably get more data. And again, this is just a very, very simple toy example of how things work. And again, just to clarify, these two are different services and servers. In a real life scenario, these two would be different servers. The first one would be where the API is hosted. The second one would be your application. So this kind of ties the loop into how you would create an API and then consume it or help other people consume it. So I think that pretty much covers it. And I can take a few questions and also discuss deployment, because I think there are a few questions that are definitely related to deployment and concurrency and some other things. So I will probably stop sharing the screen, or maybe I can first keep it up so to show the render deployment. If I now go to the browser, and I hope, yeah, okay, so I'll just go to my personal one because I probably have my render logged in there. So this is render.com or render.io, and what it does is it lets you deploy any sort of web service. And the way this works is, if you notice, I have this API project deployed. So if you see this new button, you can select web service, and then it'll give you a couple of options. You can pull from a Git repository. In this case, I have my Git repository already added. And once you select that Git repository, you should be able to select some branches or some environments and select the language to be Docker. So what you need then is a Docker file. The thing is, what this whole thing does is, and as you can see, there's a free plan. So the free plan kind of lets you deploy the Plumber API for free. The only caveat here is that it will be shut down if you don't use it often. So then it'll need a cold start. So each time you try to run the API, and it also warns you here, it will try to run the container first, try to do that deployment first, and then be able to access the API. So again, their plans are not that expensive. If you're just using it for a very small purpose, a starter plan works just fine. And what we need to now look at is a Docker file. And the way a Docker file works is that it's a separate syntax altogether, so we will not get too deep into it. And you can actually have a lot of these new LLMs and chat interfaces create one for you. But what it does is it essentially is a script for the web service to run. And when it runs, it sets up your environment as you would have it in your local machine. So for example, you pull the latest R base image. The second step is you install renv. You install some Linux dependencies in that R image that are necessary for R to work or your project to work. And in this case, this is just a placeholder. You replace that with, for example, in this case would be ShinyConf 2025 Plumber Workshop, as long as there is a Docker file, which just looks like a file named Docker file with no extension. And it just tries to copy that and then source, do a rem restore, and then run the plumber.r. So this file can at least get you halfway through a deployment setup. But again, this is, I would say, this is more of a experiment and you will find method, because here we're exposing port 1914. The reason we're doing this is that Plumber by default runs on 1914. But if you notice our current API, we have 8008. And the reason we have that is because we set that port in our PR run function. So again, this is, your mileage may vary. You might have to change a lot of things, but then deployment is possible on not just POSIT Connect. You can do a lot of things. Docker is, I think, my recommended way to do this. Of course, it needs a few more skills that you would try to quickly grasp at, but you don't need to learn it completely. In my opinion, you can actually just go with some sort of help on the internet. And I think this file that I just shared is a really, really good starting point, because it comes from the same file that I have been using. So it works without errors, and it should be just fine. So now I think I can stop screen sharing and try to answer some of the questions. And from then, I think we can have Pavel on stage as well, because that would be really, really helpful. And I wanted to thank Pavel for being my guy in the chair. Thank you so much for helping me out for starting. You've been really active on chat. This is really, really helpful. And thank you so much. I will go here.
No problem. No problem. Great talk. Great talk.
Yeah. So I think the first question is from Robert Sepka. And Pavel, feel free to chime in whenever you feel like I'm going in maybe a different track, or maybe I'm unable to answer a question. So can I use Plumber API to create a function which plots the chart and publish it on my website? If yes, how to inject it into HTML? I think Pavel already answered this. You don't need an iframe. You can just add a script tag to the web page, and it can fetch the HTML. So you can also try to do a render HTML, and it will still, I think, most likely work. But then, yeah, I think this is a much better way. You don't need iframe for that. For concurrent requests, I would recommend going with a load balancer. The service that I just showed, Render, what it can do for you on a paid plan is that it can spawn multiple servers. So again, with concurrency, there are two methods. One is you can scale horizontally, or you can try to spin up more Plumber instances on the same server. In that case, your server kind of tries to go bigger and becomes vertical. So I somehow like scaling horizontally makes more sense, because then you can shut down those instances as well. What render lets you do is, if there are concurrent requests, it spawns up a new server, handles the second request, and then once that request is done and no other further requests come, it will shut down that. But again, it costs you for each server. So each instance that you spin up will cost you more. But Plumber natively cannot handle concurrency. You will need to figure out some way out of Plumber to do this, probably from a DevOps or infra perspective. For Entra ID, yeah, I think I have not experimented with it yet, but I feel that you should be able to get some sort of authentication working with either Auth0 by Okta or Firebase, and I think that can work. I think Pavel already linked to a good article for Firebase, so that might just work out. Um, then David asks, as Venkat asks, in what scenarios could we use Plumber? Is it useful when we have to send a potentially heavy data for input output? For spatial data, um, I agree with Pavel. The best use case is to offload the Shiny application for some expensive logic. So it's less of the size of the object that's returned. It's more of how much of your Shiny app, or for example, your script will have to wait for that data to be computed. And I think extended task in Shiny is a really good, I would say, step into making both of these things work together as a puzzle. So if you offload some really expensive calculation into a Plumber call, and then you use extended task, you can essentially offload and get async-like behavior in Shiny. I also feel sharing a model or sharing some model artifacts, if you're a data scientist or a machine learning engineer, would be really helpful. For example, sometimes you create a model and then you want everyone to have access to that data, but then you retrain that model and then everybody wants different, I would say, different params or different results from that model. And you can historically store them and somehow use the Plumber API to fetch them. And that could be a really good use case. I know this because I've kind of suggested this once to a friend, but then that did not work out really well because it was too heavy. But then again, the initial use case that they suggested is just to send some model parameters out, which would be a small JSON of 10 elements. So this could be a passive sharing of results as well. For SAML, JWT, OAuth authentication can be authorized based on roles. Yes, I think Pavel already has that answer down. I think Johan has a really, really good use case. And I agree, DigitalOcean and $10 a month is a sweet deal. And there's also documentation on the Plumber, the actual Plumber docs, to have a one-click droplet for DigitalOcean. In my experience, somehow I never got that to work. So I had to spawn an instance on DigitalOcean and then use PM2 inside of that. But I know that it works because they have that in the documentation, and that seems to be really documented. So they document really well. And it seems Johan was able to get that to work just fine. So I think I'm now of the opinion that I was doing something wrong, which is more often than not. So I think that is a good end to the questions. Thank you, Yuan, for sharing the example of hosting on DigitalOcean. If there are no more questions, I think I invite you, Pavel, to share some of your thoughts on how you would approach APIs, how Plumber works for you if you've used it before, or some use case that you might want to share with someone without maybe potentially sharing something sensitive.
I think, as I wrote on chat and as you mentioned, the for me personally, the best use case for Plumber is offloading the Shiny app, because Plumber itself is arguably not a very fast API library, and to use it, you need to have a good reason to do that. And one of those reasons is you already use our Shiny. Another reason, you are really embedded in our workflows and you need our functionality. Otherwise, I like fast API better, but that's Python. I think the auth question is like a huge question in the chat, but unfortunately, it's not easy to answer it simply, because it's not always a simple thing, but a pattern is usually very common. So API receives a request that contains either a header or a query parameter, which says ID or user ID something something. And then inside the endpoint handler in Plumber, you would want to use HTTR or anything else to make a request to the authentication provider, for example, Azure AD. And you would do that because you have client secret and tenant ID and anything else that you might require stored as environment variables securely on the server. So you make a request to the authentication provider and you get back the information. Is this header valid, or does this user ID exist, and what is their role? Oftentimes, this information is transferred via JWT, JSON Web Token, and JSON Web Token has a standard for which fields are present there, but you can also modify it and add custom fields there if you hand roll your authentication system. But it's not easy to answer this kind of question like in a single sentence, because you would need to get plumbing on a relatively low level.
Yeah, I agree. I think it's a very non-trivial use case, and again, it depends on your organization. Let's say you use Azure or MS Intra ID, or you use something else, and then you would kind of be bogged down in the specific details of what you are stuck with. And I think something that you also said, that if your workflow or your use case or your team is too entrenched into R, I think Plumber is a really good way out of taking that all that logic out. And again, what this enables you to do is, in my opinion, at least that's my vision for my own apps, to not be tied to Shiny. Even though I love Shiny, I would still say that there are moments where you think that you're kind of running in circles just to do something very basic that you would have done in something else, for example, vanilla HTML or React or something else. So what Plumber lets you do is take all of your logic that you've already written in Tidyverse or something else, and then just bring it out into, let's say, a React app. And maybe you can then down the line get into Python or Fast API, but at least it lets you whip up all of your code out from the RScripts without anyone knowing how the RScripts are working behind the scenes. So again, it's a very good way, in my opinion, to abstract things out. And I think that was my goal with this workshop, to kind of use Plumber and unclog your R scripts, because a lot of great analysis is hidden inside of organizations. But people always wonder, it's very difficult to share this because this is not a lot of analysis, first of all. Second, I don't know how to create a package. Creating a package would be a hassle. Then I need to maintain it and so on. So with Plumber, I think the maintenance is fairly low on the code side, more on the, I would say, platform or infra side. But then if you are able to at least leverage some of this or some of what you've seen today, or I would just say, as I always say, steal my code and you make something great out of it, I would recommend doing that, because I think all good coders steal code. And half of this code came from somewhere anyway. So I would say this concludes the workshop. And I hope you got something out of it. At least, if nothing else, it tickled your brain to take something out and suggest your team with a new solution that you just saw on ShinyConf. Thank you so much for attending, everyone.